accepted, challenge accepted. The attitude is always challenge accepted. Challenge accepted, challenge accepted. The attitude is always challenge accepted.
And our next speaker arrives here directly from neighboring Serbia. As you know, Serbs are notoriously good in back-end development, front-end development, and servers. And today we have one of the best front-end with us.
Nikola is an experienced JavaScript software engineer with expertise in front-end development and passion for web performance and user experience. He has spoken at conferences like Developer Week Europe and DevBCN.
Please welcome the Djokovic of the front-end development,
Nikola Mitrović!
Challenge accepted, challenge accepted. The attitude is always challenge accepted. Challenge accepted,
Thank you.
challenge accepted. The attitude is always challenge accepted.
Challenge accepted. I wish you a warm welcome to today's talk. Today we're going to talk something called Web API. But before we do that, we need to take one step back and go to some JavaScript basics. Can anybody tell me what the output of this code would be? Anybody, please? Sorry, I can't hear you. 1, 3, 2, right? Great, that is an excellent answer, that is correct. But may I ask somebody, how do you know that? How do you know that's the result? Okay, correct. There is something called event loop, right? But that's just a bit half of an answer, right? There is some intermediate steps between. Okay, let's visualize this example a bit. We know that console log is synchronous, right? It goes to the call stack, and it gets executed immediately, right? We know that setTimeout is async, and it needs to go away from the call stack, not to block the main thread, because JavaScript is single thread, and it needs to wait somewhere. Then console log 3 comes along to the stack, gets executed, and then once the timer has passed, your server correct, there is something called event queue, and then event loop checks if the call stack is free or not, and then kicks back the call back in. But the question is, where does the setTimeout wait? And if we Google that a bit, we can see that the first result is this. If we click on that, we see the documentation for the setTimeout, and there is something called Web APIs. If we read that, we can see that that is just something that is provided by our runtime environment, which is the browser, and there is a huge list of these kind of functionalities that are provided from our browsers right outside of the box. And if we look a bit, there are a lot of these APIs. Now tell me, has anybody ever built a file upload component? Something like that on a front end? Okay, some of you. I'm guessing you've used local storage, session storage. Has anybody used web workers or service workers? Okay, great, some of you. So basically, those are all web APIs. We can use them without using any libraries because it's provided by our runtime. And looking through this list, I was just curious and wondering, okay, if I know about some of the APIs that we use quite commonly, what are some of the exotic APIs that we are not aware of but can help us? And basically, that is the question we will answer today. And the question to the previous answer was Web API. setTimeout is a Web API function. So we can say that Web APIs is just a collection of those interfaces that we might use right outside of the box. A little bit about me. When I was in high school, I always wanted to study psychology. Now I work at my dream job at Vega IT, based in Novi Sad, Serbia, where I work as a development lead, which means that I teach people soft skills. I teach them how to communicate with a client, how to do presentation, obviously, how to estimate tasks, how to deal with stress, and so on and so forth. And of course, I'm a front-end engineer. My name is Nikola Mitrović, and these are my Web APIs highlights for you for today. Before we do that, I'm going to show some code during the presentation. I understand that people in the back might not see the code properly, so this is the QR link to the slides themselves. So if you had trouble seeing that console log example, you can just scan it and put it in the landscape mode and follow along with me if you have troubles. While you do that, one more information for you about this presentation. The examples that I have built are built in React. Few reasons for that. React is probably most popular framework or tool in today's web development. And the other one, it's simply I'm most comfortable with the ecosystem of React. But if you do Angular or Svelte or Vue.js or anything, please focus on the concepts because the concepts are there, the concepts are solid, and the Web API is basically the standard that should work in all browsers, right? Okay, that being said, we move on to our first example for today. Let's say we have a page like this, and once we scroll a bit, we start noticing in the top left corner an astronaut, and once that astronaut is fully visible, he says, "Hello world." We move away a bit, the message goes away. Once it's visible again, he says, "Hello world." So, how did we manage to do this? Of course, there is an API for that called Intersection Observer API, which basically just figures out if elements is visible on the page or not. If we build a hook in React, we would probably call it useVisible or something, and that hook would accept two parameters. One parameter would be the reference of the object that we're trying to observe, and it has the second option is configuration object. That configuration object might contain the property root, which is the ancestor of the element that we're trying to observe. If we pass null, then we assume that we're observing according to the viewport, to the whole document. So we can have some mini containers with a scrollable content. Then we can pass a second reference. We have a root margin, which is a margin around that intersection if we want to get that intersection a little bit earlier. And we have a threshold. You may notice that astronaut was fully visible, which means that the threshold is 100%. Now we can configure that if we need it a little bit differently. We would have a state is visible, and now we instantiate intersection observer object. In the callback, we get entry object, which has is intersecting property on it. And basically that property contains information if the element is visible or not. We pass the configuration options. And what's left to be done, it's just to observe that element and return that state. And we would get true or false from that hook if element is visible or not, right? That example with an astronaut was cute and nice and whatever, but probably you're wondering, okay, how can I use this in a real-life example, on a real application? Basically, we could lazy load images. We could optimize initial load of the page. So we load only what we need, and we defer other assets that we might not need. And once we scroll to the certain section, then we load that image. We could create infinite scroll lists. So for example, we don't need the library for that. We could have a list out of, let's say, 10 elements, and we have a separator div. And once we scroll to the end of the list, intersection observer kicks in, and then we send our next request, and then list gets populated and pushes back that separator at the end of the list again, and so on and so forth. We could defer some animations, so we don't need to run some JavaScript code or some animations if the user is not observing that part of the screen of the application. And in that sense, we can save some computer power. One thing to consider always when using with these APIs is browser support. Now, not all browsers have the same implementation. If we look at the major vendors, we can see that intersection observer is fully supported. So it's safe to assume that we can use this in all browsers. Although all browsers comply to this web API standard, they do not have the same implementation. And that's a thing to always consider when using these APIs. OK, moving to the next one. Let's say we have an audio component like this one, and we play it. But once we move away and go back, the audio stopped. We play it again. Then we open a new tab. Then we go back. The audio stopped. We do that again. And I cannot minimize the window. Sorry, I thought I could. But again, it would stop in that case. So how did we manage to do this? There is an API, of course, called Page Visibility API, which provides the visibility of the whole page state. And it can trigger if a user switches tab, minimizes the window, puts even another window as an overlay to your app, or locks or turns down the device. The hook would look like this. So again, we would have a state. And then on a document, we add event listener visibility change. Once that callback is triggered, then a document, again, has visibility state, which contains the state of the visibility of the whole document. And then we put that to the state. Some of the real-life use cases, again, for this one, we can improve performance. We don't need to run some code if user is not observing the page, right? We can pause audio or video. Imagine this feature. Let's call it focus mode on Udemy. If you're not looking at the tutorial, it just stops. Like you play it in the background, you're just saying, I'm listening, I'm absorbing everything. No, you're not. We can detect page visit count. It could be useful for some analytics. If we go away from the page, then we go back, usually JavaScript wouldn't kick in again, and then we would lose that real user visit count for our pages. And we can stop polling from the server. If we have some polling mechanisms and the user is just not viewing the page at the moment, we can stop that and put our server to a little bit less stress. And we can, again, stop some, for example, carousel. We don't need to run it, that code, if user is not observing the page. Again, browser support, if we look at that, all cool. They say everything is cool. We can use this safely. OK, moving on to the next one. Now, I'm in my personal preferences. And you may notice that my laptop is not on a charger. If I put this setting to save the power if I'm not doing anything, right? If I'm idle, then my laptop should turn off after 1 minute, right? But we're gonna see about that. Now, you may notice that I didn't speak much about myself at the very beginning, but now I have a minute to spare, so it's my time to shine. I like to travel, and when I do, Italy is probably one of my favorite destinations. Architecture, the nature, people, I don't know what's about this, but it's so amazing. I don't know what's about this gesture, so much passion, you know. It's so fun to speak like this. Of course, one of my favorite things about Italy is their cuisine. So when I come home recently, I like to prepare food for myself. I go to some cooking website and I prepare food. And after 1 minute, this happens. Or this happens. No. Okay. That's because I have the most amazing feature in this app, which says, hey, I'm cooking, do not turn off my screen. So now I can prepare my food in peace without needing to turn it on again. Okay, let's put this back. And let's see how did we manage to do this. There is a screen wake lock API, which basically prevents locking the screen, although the personal preferences say something different. And it only can be used if the document is visible. If we build a hook in React, first we pass that toggle state, if it's turned on or off, right? But here, situation is a little bit different than we used to have. If we turn that toggle on, we would call a request wake lock sentinel function. That function is calling on a navigator. We have a wake lock object, and then we call request method with a screen parameter, which will basically get us the reference in memory about that lock. Now, the question for you is, can anybody tell me why is this a promise? It didn't used to be with the previous APIs, right? But now it is. Okay, we can leave that for later. You can ask me about that. Okay, so it's a promise. And this time, we need to put that in a reference, because if we put it in the state, we would lose it next time it updates. But we need to clear exactly that reference that this promise returns. Otherwise, once we release the lock, it wouldn't work. And now that we have done that, we just return that, okay, we have now the lock object. And if we want to release it, we call release method, and then we need to call release method on that very reference, and then we need to clear that reference. So we need to do both of these things, otherwise it wouldn't work. Okay, some of the real-life examples for this one. If you're reading an ebook, you don't want your device to turn off, right? If you're presenting to the audience, as I'm at the moment, if you're following the cooking recipe, if you're using some map navigation, or if you're scanning QR or barcode. Let's see what browser support says in this case. Okay, it's a little bit different than it used to be. Okay, Chromium-based browsers have support, Firefox doesn't, and this sign here means that it's in experimental phase. So Safari has some groundwork put in, but it's not fully production ready. One more thing to consider when using this API is device support. No matter how hard I tried, I couldn't make this work on my iPhone. I think it has to do to the fact that Chrome on iPhones is just basically skin for the Safari. It uses WebKit under the hood and not Chromium engine. So I assume that probably it has something to do with that. So we would need to wait a bit for this API to work fully. OK. Now we go to our next example. Here we have example of svemirko.rs. Svemirko is a little bit, translated to English, it means spaceman, roughly. It's a little bit futuristic app, few thousand years in the future, where you can go to this app and you can discover some planets where you want to go to the vacation. In the backend, we're communicating with the NASA's API, and now we have the list of all habitable planets, and we can, for example, TOI 1136G, sounds amazing, always wanted to go there, and now we can reserve a flight to that planet. Okay, but what if we are experiencing some network issues? I know it's a few thousand years in the future, but hey, it could still happen. So if the network is a little bit slower, then we can show the message. But note that it's not just about the network, the time of the request. It's about reacting to the network changes as well. We can do this with the help of the network API, which basically provides the information about our system connection. And it can detect connection changes. How can we do this? If we write a hook called use network, we would also have a state, is our network fast or not? And then we have to check for the connection object inside of a navigator. I will get back to that right in a second. Why is that important? And then on that connection object, there is an effective type. And that effective type can have some of these values. So we assumed if it's slow 2G, 2G, 3G, or 3G, then it's a slow network. If it's a 4G, then it's a fast network. And we just put that in the state and return that state. And that's how we managed to do that, displaying the message. And how we reacted to the changes is on a connection object, we put an event listener change. And once the callback is executed, then again we extract the effective type and set it to the state again. And pretty much that's it. Some of the real-life use cases, we can display some notification to the user, or we can preload large resources. So if it's a fast connection, we can do some performance optimizations. If it's not, maybe it's not the right time to do so. And again, browser support in this case, not so good for now, but we will have to wait a bit. And then again, the same example we had before, but we didn't cover one of the most essential use cases in today's web developments, and that is, what if our application goes offline? So what if the network isn't slow, but we go offline? And if we hover over this link, it should trigger a request to some performance pre-optimizations and retrieve the list of the planets. But can anybody tell me what would you expect in the network tab if the application is offline and you're trying to send a request? What would you expect to happen? Yes, please. Yes, we would see that request in the network tab, and it would be red, and failed, right? But in this case, it didn't do that, but it did something different. In the application tab, we have a background sync, something that is called background sync. And there we can see that we registered an event. And once we go to the second page, and we're waiting for the planets to load, and then internet kicks back in, there is an event called dispatched event. And once the request is finished, then we have sync completed event. So what's going on there? There is a background sync API, of course, to do that, which will help us to defer some task in the background into the service worker, because service worker would help us to deal with offline states. If we have a component in React, like in the previous example, we had a link. Once we hover over that link, we would call a function, which will, on a navigator, access to the service worker and to the ready object. That's it. That is our background sync registration. After that, what is left to be done is to call sync and register a background task with a certain name. The reason for this is that we might have multiple tasks that we would like to run in the background. And inside of a service worker, now we have a task by a tag name, and we check for that tag. Once that event happens, then we can trigger the request to our backend. Some of the real-life use cases, of course, improving offline user experiences, and maybe sending an email while you're offline. You click a button that should send a request to send an email, but connection breaks, and you're not aware of that. The task will be registered in the background, and once internet kicks in again, then it gets executed without you worrying about it. Browser support in this case, well, again, not so great, but it will get better, I promise. Now, in the previous example, you might wonder, okay, on the left we have a React component, on the right we have a service worker. So now once we trigger the request and we get the data, how can we pass that data to our component? There is a neat API for this called Broadcast Channel API, which basically allows communication between same browsing contexts, which can apply to the window, tab, frame, iframe. The important part is that two components are on the same origin, and that's it. And it goes both ways. So if we have, in our service worker, we would connect to that channel, we would create a new broadcast channel, and then once we get the data from the backend, we post a message with that object. Inside of our component, we subscribe to that very same channel, and then we listen to on-message event, and that will contain our data. Some of the use cases, again, detect user action if user is doing something specifically that we want to detect. Or, for example, if we have application opened in multiple tabs, we log out from one, it automatically logs out in all of them. Browser support in this case, all cool. We can safely use this API. Finally. Okay, since we don't have too much time and there are a lot of APIs, I just displayed some highlights for you today, but I have some bonus points which I plan to investigate in the future, so you might be interested in these ones. There is a beacon API. The use case is when you want to send a request, but you don't care about the response, and it could be useful for some analytics. Web speech API, which can detect our speech and even do speech to text. Web share API, if we want to share some data between the same devices. there is a background fetch API. Basically, if you're trying to download a huge resource and then we go offline. And probably one of the most exciting APIs from recently is web authentication APIs. So passwordless future is ahead of us. We don't need to remember passwords anymore. We could just log in or sign up with our Touch ID or with our face, and it would be much more secure than it used to be. And some takeaways. We've seen that some of these APIs are not fully supported by all browsers. Some of them have experimental support. Some of them are lacking device support. And there is quite lack of TypeScript support. While I was building these examples, I had to put a lot of NEs there just to type something manually, so we don't have packages for all the typings. But why should we use and leverage these APIs? Because it's standardized code, it's standardized code, it's standardized code. I probably could not stress enough how important this is, especially in today's web development, where there is a new library each week or a new framework, and you have to learn everything from scratch. This is our single source of truth. These APIs are standardized, and we know that they are going to work for a long period of time. So if you build a file upload component a few years ago, the chances are that it still works. If you have used the library, maybe, maybe not. Again, most of these APIs are easy to learn. They're not that super complicated, super hard. And they can increase performance as a side effect. What I mean by this, for example, that infinite scroll list, if you use the library, it would increase the bundle size of our apps. If you use intersection observer, the increase of bundle size would be minimal. So why use something when there is something offered right outside of the box from the JavaScript, from our runtime environments or whatever? It could be pretty easy to build something like that with just native support. And that brings me to my next point. With great power comes great responsibility. Does anybody know who said this? Sorry? I'm not sure. Maybe. Could be. Could be multiple people. Yes, that's Uncle Ben from the Spider-Man. I came here today with this kind of power, let's say. So I felt it's my responsibility to talk about this. I wanted to talk about our planet. Okay, I can see some of 404 not found facial expressions. Like, what? Well, what I mean by this, we build our front-end applications. Output of that build is our HTML, CSS, and JavaScript files. We put that bundle on some cloud provider, we deploy it, right? Those cloud providers are spread across the globe. Basically, they have multiple data centers. Those data centers have a lot of computers, and those computers are plugged into electricity. In fact, they use so much that internet consumes 21% of the electricity in the whole world. I don't know about you, but this sounds very disturbing to me. Luckily for us, there is a website carbon calculator application which can do and check these things for you. So please, if you have a web app, go to website carbon calculator and check how green you are. This is super important because our planet is our home. We only have one home. So if we mess this up, There's no going back. When I was building Svemirko, I was much more thinking like in that Dua Lipa song, if you want to run away with me, I know a galaxy and I can take you for a ride. Much more than Interstellar, the movie. I'm not saying that we should all, become environmentalists or whatever, but we should at least care for 1 or 2%. Because if we raise the bar to at least that, if we join forces all together, we can create a big difference. Challenge accepted? Okay. Our planet is our home. We only have one home. If we don't care about it, if we choose not to care, then one day, might be too late. Thank you so much for coming today.
Thank you, Nikola, for being such great talk, for this great talk, and for being environmentally aware. Please applaud Nikola Mitrović!
Challenge accepted. Challenge accepted. The attitude is always challenge accepted. Challenge accepted.
Here is the
Challenge accepted. The attitude is always challenge accepted.